my name is Flor Espinosa. I'm a mathematician, and in this video, I would like to show how mathematics can be used in real life by showing an example of how the coronavirus may be spreading. How mathematics can be used in real life is a typical question that students ask in math classes all the time. So I would like to emphasize in this video, I'm showing a very simple model that can help understand how the coronavirus may be spreading and how we can uncover or build a mathematical model from this kind of spread. You may ask the question by this time, why some communities or countries don't have the coronavirus yet? The reason is because for a virus or an infectious disease to spread, we need at least one infected person in the community to start the spread. The first infected person is referred to as patient 0. So now, let's suppose that this infected person gets to infect 2 people. And these 2 new infected people get to infect 2 people each. And these new 4 infected people get to infect 4 people each. And if we are recording this new number of infected people per day, we can notice that the new number of infected people is doubling each day. So this is a characteristic of an exponential growth because the new number of reported infected people is growing pretty fast, in this case doubling its number. So let's try to uncover how we can represent this mathematically, the new number of infected people. At 0 day, we have 1 infected person, and that one number can be written as 2 to the power 0. The first day, we have 2 infected people. 2 can be written as 2 to the power 1, where the power here is a number, the day number. By the second day, we have 4 infected people. This 4 can be written as 2 to the power 2. If we continue this way to the 5th day, 32 new number of infected people can be written as 2 to the power 5. As you may notice the pattern now, the new number of infected people can be written as 2 to the power number of day, the day number. So this spread can be represented with an exponential function y equals 2 to the power x, where x is a number of days bigger, positive, or equals than 0. And the y-axis here represents the new number of infected people. As we notice here, I plot the data that was extracted from the spread model, and for each day number, it has the corresponding value in y. Now, if we move 1 unit in x, we notice that by moving 1 day in the x-axis, y doubles its value from the previous day. Again, this is an example of a characteristic of the exponential function. And we can say that in this case, the spread of this virus is growing exponentially. If we want to know the total number of infected people by the 5th day, then we have to do a cumulative sum from the 0 day to the 5th day. In this case, I already did a sum, it's 63. With this kind of spread, this virus, as the number of infected people is growing again exponentially, without considering any other factors such as intervention. How can we reduce the spread of this virus? Doing what we're doing right now, social distancing ourselves from others. Here, if this person doesn't get to interact with these people, then all this branch can be reduced. The number of new infected people can be reduced. So the same way the spread grows exponentially, we can decrease the spread exponentially as well. The other thing I would like to emphasize about mathematical models, that they help us, once we have a formula model, we can make future predictions. For instance, with this formula y equals 2 to the x, we can find the number of infected people by the 10th day. And so, how far can we go in days? Well, it depends on the total number of population and the community, or home day. I hope the video helps you understand how mathematics can be used in real life and the importance of paying attention in your math classes. Thanks for watching.